7.3, we are still dealing with forces. We're going to specifically talk about Newton's laws. So we got 3 of them to go through. We've got a lot of different math going on. We're going to talk about, I think, 3 different formulas. So make sure that you've got a calculator ready and you've got those triangles going and things like that. So first one, Newton's first law of motion, also known as the law of inertia. Okay, law of inertia. So in the absence of a force, an object in motion will remain in motion, or an object at rest will remain at rest until acted on by an outside force. An object in motion will stay in motion. An object at rest will stay at rest unless acted on by an outside force. So the object will keep doing what it's doing until a force comes along and messes it up. Okay? That's essentially what it means. An object will stay doing what it's doing until something comes in and pushes it along. All right? Just like with you in school, you might be doing something and then somebody comes in and makes you work even harder or something like that. Okay? Now let's talk about this word inertia a little bit. It's a funny word. It just means that there's a tendency for an object to resist change. I mean, it's natural. It's hard for people in general. It's objects, things like that. It's hard to change, and so you have to have this force to get you to go. Objects are the exact same way. The harder it is for it to move or to change its motion, the more inertia it has. And that's what happens here. More mass needs larger forces to change. Okay, so it's like pushing a professional football player versus a professional ballerina. Football players tend to be a little bit heavier, so it's harder to get them to move than a ballerina. Okay, so that just means inertia is related to mass. More mass, more inertia. With this comes momentum. Momentum is, so like if a car crashes and let's say you're in it without a seatbelt, it's your tendency to keep on moving as the car crashes because your body wants to keep moving unless a force acts on it to change it. And that's what the seatbelt's there for, to stop you from keep doing what you're doing kind of motion. So momentum is how much force is needed to change an object's motion. Your equation is P equals mv. P stands for momentum. M stands for mass. V stands for velocity. So let's talk about some units here. Let's talk about the ones we know first. So mass, remember, is going to be in kilograms. Velocity is going to be meters over seconds. So what that means is if you're going to take mass times the velocity, momentum gets this funky unit of kgm over s. So the one with the complicated unit is going to be momentum. Okay? Now let's talk about our triangles. So for every formula that I give you, you need to make sure you know what all the letters stand for, you need to know their units, and then you got to be able to do the triangle. So let's do our triangle. Okay? So in this one, these two are already multiplying together. So you're going to put M and V on the bottom and then P on top. If the two are already multiplying, they go to the bottom. Okay? All right, so we're going to go straight into another formula here. So Newton's second law is the amount of force that is necessary to accelerate an object depends on mass. So amount of force depends on the acceleration and the mass of the object. So you get this formula, F equals ma. F stands for force, M stands for mass, A stands for acceleration. Units, force is going to be in newtons, mass is in kilograms, acceleration we've already talked about, meters per second squared. The triangle, very similar to the one we just did. M and A are already multiplying, so you're going to put M and A on the bottom, F on top. Remember every formula I give you. Know the letters, know the names, units, and triangle. So let's do an example here. What would the acceleration, you're looking for A, of a 10 gram, now it can be grams. Actually, no, let's go ahead and change that to kilograms. It should be kilograms. 10 kilogram object be if 5 newtons of force were applied. So 5 newtons is going to be your force. Kilograms, remember, is your mass. Okay, so you're looking for acceleration. Grams is dealing with mass. N means you've got your force. All right, so let's do our triangle. Remember, if you go back here to this, you've got F on top, M and A on the bottom. We're looking for A, so we're going to shade in A. So we get A equals F over M. So F is 5, M is 10. So all you're going to get is 0.5 acceleration meters per second squared. Done. Okay? All right. With Newton's second law, we're still in Newton's second law, you need to know a little bit about weight and mass. So weight versus mass. So if you look at the weight on Earth, so my weight on Earth is around 560 newtons. My weight on the moon is 90 newtons. Why? Why are these two numbers different when dealing with weight? Because they have different gravities. Okay, it's not that the moon has gravity. It has hardly any, but it has gravity. Okay, it has a lot less. That's why you go from 560 to 90. Now, my mass is always 56 kilograms. That is not changing. This is what you need to make sure you know. Weight changes because of gravity. Mass does not, because remember, mass is the amount of stuff, of matter. Okay. Weight deals with gravity, mass does not. So that's what this is here, okay? Mass is how much matter an object has. Weight is the force of gravity. So mass does not change unless you add more matter, okay? Weight changes depending on gravity. Now, this equation here is literally the same equation that we just talked about, but instead of having an A, we're going to have a G. And what does G mean? We'll talk about it right now. So FG, now that's just a little g, it's just force of gravity. You're not using G twice in the formula. FG stands for force. M still stands for mass. G stands for gravity, and if you remember from previous video, that just means your acceleration of gravity, which is 9.8 meters per second squared. That is given to you on your reference table, okay? So let's talk about some units. Again, force will always be in newtons, mass will be in kilograms. Triangle is the exact same one we just did. You have M and G on the bottom, F on top, okay? So let's talk about what's going on here. So Jesse has a mass of 200 kilograms. So that is your mass. What is the weight on Earth? Now weight is the same thing as FG. Okay, so you might want to include that with your notes here. FG is the force of gravity, which is also known as your weight. So if I ask for the weight of something, this is the formula you're going to use. Okay? So you're looking for FG. Now, kids get a little bit confused about these questions because it looks like it only has one number. What the heck am I supposed to do with one number? You've got to remember that you also know G. You know G is 9.8 meters per second squared. Okay, so if we do our triangle, FG is on top, MG on the bottom. So all you're going to do is MG. So 200 times 9.8. 200 times 9.8, and you get 1,960 newtons. Now we're not doing pounds, we're doing newtons. They are two different units. Okay, now let's talk about the third law. Newton's third law of motion. This is probably the one that people know the most. For every action, there's an opposite and equal reaction. So what does this mean? If you were to jump off a boat, so this is the person jumping off the boat. The person goes this way, the boat goes that way. Because what's happened is Since you're moving that way, you have to push off the boat, which makes it go the other way. Rockets, same exact thing. You have the thrust by the gas going that way, therefore the rocket goes that way. For every action, there's an equal but opposite reaction. So this is just another example here. If I push against the wall with 100 newtons, what is the reaction force? The wall is doing the exact same thing. Okay, so if you push on somebody, they're going to push the exact same weight back, or the exact same force back. Now, what your body does to that force might be different, okay, but you're pushing the same force on each other.